Great. Hi, I'm Mike Zyda, and today's talk is building a human intelligent metaverse. I'm going to share my slides. All right. I want to hit on play and then drag this piece over there. All right. This is based on a paper I put in IEEE Computer Magazine. So let's move on. My bio, I'm an ACM fellow and IEEE fellow. I'm a USC professor of engineering practice. I'm an advisor to 11 plus startups globally. I've been an expert witness on 36 law firms, 49 cases of patent litigation for 58 game computing companies. And my website is mikezyda.com. So this talk describes a potential research agenda on computational human perception and its potential at being core for the creation of a human intelligent metaverse. Now, this is not at all the same as the Game-Mod Metaverse, the GMM, currently being flogged to the venture capital community. The creation of a human intelligent metaverse, a sensed world that reaches out from the computational infrastructure and interacts with our physical, emotional, and mental states is a big future for humanity. In the paper I wrote in March of 2022, entitled Let's Rename Everything the Metaverse, I pointed out that almost every network game was being renamed and repurposed as a portal to the metaverse. As far as I could see, there was not much difference in these various metaversi, that they seem just to be network games with the ability for the player of being able to create their own 3D avatar, with some advertising the ability for the game player to be able to create their own game inside of the so-named metaverse. Now, we have been creating our own game avatars for just about forever, so that it's not really new. Perhaps it is better looking 3D this time, but the idea is not new. Now, we used to call building a new game inside of another game a game mod, and such mods have been around for a long time, with probably the most popular one I can think of off the top of my head being Counter-Strike, which came out in 1999. I built an entire game development team out of hires from the Counter-Strike mods community, and we got to build the America's Army game together. So what is new about the various metaverse portals? They just seem like something we have seen for years. Well, they certainly look nicer graphically than what we were building in the 2000 timeframe, but are they all that different? Or is the metaverse just a marketing term, one to satisfy the desires of venture capitalists so that they can say they're investing in something new, not just something where all the key features were straight out of 1999? And on top of this rebranding effort, we also have the crypto squad and the NFT mavens all trying to hang their scammy little selves onto the metaverse so that perhaps they can grab hold of some of that VC lucre. And most of the smart money people I know are running away from crypto and NFTs as fast as possible. The only people I know still going after crypto and NFTs are those people who are hoping beyond hope that they will catch something akin to the Bitcoin run-up that they all missed earlier in this last decade. And I know two people who made money on the Bitcoin run-up. One, a former child star who took all his winnings to Puerto Rico to avoid capital gains taxes. And one was my TA for my mobile games class. And he got his Bitcoin by winning a contest, and he lost track of the Bitcoin for a while until he realized that he could pay off his USC tuition with those winnings. The rest of people I know invested in Bitcoin long after the run-up and are now watching it rapidly lose value and are hoping beyond hope that NFTs will save their sorry souls. So, desiring to throw my hat into the ring for what we really ought to be doing with the metaverse, idea number 32,768 is to create a human intelligent metaverse, a metaverse that is designed around the idea of sensor-based games. The idea is this: we want to utilize biosignals captured from sensors, the interpretation of those biosignals, physical state, emotion state, and mental state, and behavior models for building a sensed world capable of modeling and interacting with humans. We call this the Human Intelligent Metaverse, as opposed to the Game-Mod Metaverse that is currently being built. Let's start by describing what we can do with the Game-Mod Metaverse, the GMM. With the GMM, we can put on a head-mounted display, perhaps put on some sensors that track our body's motion, select our 3D character's avatar, and enter into a game mod of the metaverse we entered. Now, our interactions in the GMM are just responses to the visual display that we see. We make sense to physical movements in our navigation of the user interface that is unique to this GMM experience. The GMM does not care about your emotion state or your mental state as you play against whatever game mechanic has been built for you. In the Human-Intelligent Metaverse, HIM for short, we are using biosensors that can be interpreted into physical state, emotion state, and mental state vectors. Let's call them human behavior vectors. And we can take those human behavior vectors and now do interesting things with that additional information. We might start with the mental state and emotion state of the human player and pass that along to the main AI character. That AI character will have a virtual physical state, a virtual emotion state, a virtual mental state, and a personality and role in the Human-Intelligent Metaverse. The AI character will examine the mental state and emotion state of the human and generate an appropriate response based on the AI's personality, role, and virtual states. For example, if the AI is a pirate in the Human-Intelligent Metaverse, the role of the pirate might be to put the human player off balance. It can compute what to do using the human behavior vectors as intelligence. If the AI is a sensitive character in a well-storied drama, it can use its role in the drama and human behavior vectors as information on how to properly interact with that human. We go from just having physical engagement, the GMM, to a human-intelligent metaverse that can understand and interact with humans physically, emotionally, and mentally. We have something quite different. So this all sounds great, but can we do this now? The answer is we can do some of it, but not all of it now. There is much research to perform, both technically and with respect to design. We can probably build a 1.0 version of the technology now, but if we're going to turn the HIM into a consumer-facing product, then there's a significant new design research that must be carried out. We need to research how we draft a design document that utilizes the human behavior vectors generated from our interpretations of the biosignals. That's a big deal. To carry out this research, we propose a new laboratory, the Computational Human Perception Laboratory, along with a new degree program, a Master's in Computational Human Perception. And by the way, a lot of these ideas I worked out with the Stanford Human Perception Laboratory, and I was trying to convince them that it really should be focused on the computational aspects and that we need a degree, and we're still in discussion on that. Now, it's unusual in most universities to create a degree program for a particular new research direction, but I think that's actually the future. I think we're going to have pop-up degree programs that go off and help solve research problems through students cracking on the topic. Now, most universities are stovepiped, meaning they have departments whose degree requirements were determined decades earlier. It is hard to make meaningful new research happen with such limitations. Hence, we propose this new degree program to match our research in computational human perception. And the focus of the Computational Human Perception Laboratory is to create technologies that can utilize biosignals, their interpretation, and behavior models for building a human intelligent metaverse or a sensed world. I kind of use both terms in this talk. We use the term sensed world as shortcut for network virtual environment fully infused with sensors, okay? And this metaverse will understand human physical state, emotion state, and mental state as sensed and interpreted from biosensors. And characters interacting with the sensed world will have their own virtual physical state, virtual emotion state, and virtual mental state that will guide their interactions with humans. And this metaverse will be core to the future of online interactive education, online interactive entertainment, and online interactive telemedicine, as well as many other applications. And research directions for this laboratory are many and are depicted in the illustration in the next page. And we provide a list of potential research topics rather than a full explication, as this article has a word count limit. So you'll see Computational Human Perception Laboratory, and you'll see there's a piece of human sensory, human machine interface, human intelligent AI, 2 applications. And the applications of this area are all over the place. They're military, they're entertainment, they're business, biotech, education, social sciences, pharmacology, automotive, robotic, and clinical applications of this tech. So if you start on the left-hand side, you'll see biosignals. We're thinking neurosensory, we're thinking biometric, we're thinking electrophysiologic. On the human machine interface, we're thinking of natural language processing, computer vision, sensors, machine learning and deep learning. And we're thinking about human-machine interface, where we're talking about AR, VR, XR, we're talking about gaming, we're talking about wearables, we're talking about mobile devices, the whole bit. Human HMI-based human behavior models, we're talking about models of engagement, performance, comprehension, fatigue, and emotion. And human intelligent AI, we're talking about perception, intent, and action. We're talking about knowledge graphs and context and reasoning. And this is sort of the research high end of what we're thinking about. So in biosignals, the research is neurosensory, biometric, and electrophysiologic, eye tracking, facial expressions from cameras, the development of low-cost, high-accuracy biosensors. Biosensor interpretation tools are real-time machine learning tools for interpreting the physical state, the emotion state, and the mental state obtained from those biosensors. Human behavior models, software models for engagement, performance, emotion, fatigue, comprehension, stress, workload, and mental state, models that can interpret signals from biosensors and hand you a vector of saying, this is what we think is happening. And behavior model deployment in the sense world architectures sense world architectures that can be rapidly deployed with interpreted behavior models for human and AI characters and platforms for this sense world inside of AR, VR, XR, and gaming. So interactive experience design, research on the principles of interactive design that utilize interpreted biosensors and behavior models in the sense world with display and interaction occurring on the various available technological devices used in the metaverse, including AR, VR, XR headsets, mobile phones, and tablets, and other wearables and portables. And design focus will be on interactive experience development for serious and entertainment purpose. And application, I think I went over the big list of applications that will be able to use the AI characters inside of a sense world, inside of this bounded metaverse. Now, to support the computational human perception laboratory, we propose a master's in computational human perception with the following courses. And this is we think of this as a master's, and it will lead to a PhD, I believe, over time. And each course is text descriptions followed by a mind map detailing the material to be covered in the course. So biosignals, sensors, and modalities. The purpose of this course is to provide an understanding of the available biosignals generated by the human, an understanding of the sensors that can read those biosignals, and an understanding of the human modalities that can be computed from the biosignals as read by the sensors. So this is the picture that you should have in mind, which is you have human-generated biosignals. You'll see we'll have physical state sensors, could be an Apple Watch, Microsoft Kinect-like device, instrumented gloves. You'll see emotion state, where we have emotion state vectors and their probabilities, and we have speech emotion recognition or facial expression analysis, or we have eye tracking, or we have hybrid EEG devices that tell us about the emotion state. And in the mental state, we want to know something about memory, intention, desire, belief, pain, experience, perception, and perhaps emotion as well. Sensor fusion, the idea that we have computer vision and natural language processing and machine learning that all put this together so we have computed human modalities, all right? We can use that. Human behavior models classes, the purpose of this course is to teach the principles of human behavior model design and the development of those models for the metaverse-based interactive experiences. So this course looks like this picture. Human behavior models. We have behavior model design, where we have discrete and continuous state modeling. We have hybrid EEG or EKG engagement. We have performance from hybrid EEG and discrete state models. We have comprehension from those hybrid EEG and state measurement. We have fatigue from hybrid EEG and EKG. And then we have behavior model development that can be deployed in metaverse-based interactive experiences. So you'll see we go out and define the mental state and emotion state models that we're trying to get. Emotion is mental engagement, physical engagement, surprise and response, relaxation, valence, which is like or dislike, learning or not learning, eye blink, breathing and pulse rate, in the zone or lost. Mental state is perception, pain experience, belief, desire, intent, and memory. So this is what we expect to cover. How do we model these in our human behavior models class? Behavior model deployment is basically the purpose of this course is on the deployment of the sense world architectures, the human models of physical, emotion, and mental, and AI character models of virtual physical, virtual emotion, and virtual mental in the metaverse-based interactive experiences and applications. So we have sense world architectures, are the network software architectures that provide communications between the humans and the AI characters in the sense world. And there's a software twin of the live human, including physical, emotion, and mental state, read from the sensors and their interpretation. So we have a software twin of the live human. And AI character models are pieces of software that have virtual sensors that operate in the sense world such that the AI characters can have a virtual physical, virtual emotion state, and virtual mental state that can interoperate with the collected human state and characteristics of the sense world. And this is your behavior model deployment picture, which has got sense world architectures, human models, and AI character models. And the other things underneath them are very small, so they're on the next pages. So, sense world, you've got the sense world arbiter, you've got the sense world, which is the cloud. And in the sense world, we've got world state, we've got sense world events, we have human states, we have AI states, and it's all in the network. And we have actions and states. Action and states written to the sense world by humans and AI. So this is what this picture is depicting. This is what a human entity of I looks like. It's a sensed world, world state, sense world events, human states, AI states are put into this human I. And the human of I has sensors, and he has interpretation of sensors, and then puts that into a behavior and interaction model that generates a display that shows emotion, graphics, and audio of what that human entity I is about, or thinking about, or being. And then we have actions and state that go out back to the sensed world, which are action events and human state written to the sensed world. This is the AI entity I. It's a little different, which is the AI I is on the sensed world. There's a perception system for the AI character, which means it gets to have a artificial way of seeing and understanding the world. And there's a AI perceived state. And the AI perceived state will be an AI mental state, an AI emotion state, and an AI physical state. So this all goes down to an AI behavior and interaction model, where that AI has an AI personality, it has a set of goals, plans, and strategies, and will generate and display some emotion, graphics, and audio out to the sensed world and send some actions and state back, which are action events and human state written to the sensed world. So one of the next course is interactive experience design, which the purpose of this course is to teach the principles of interactive design that utilize interpreted biosensors and behavior models in the sense world, the metaverse, with display and interaction occurring on the various available technological devices used on the metaverse, including AR, VR, XR headsets, mobile phones, tablets, and other wearables. And design focus will be on interactive experience development for a serious and entertainment purpose. So this course looks like this, and applications is the same set of applications I showed you before, but you're designing for the sense world, which is you have to write how I'm going to use the interpreted biosensors and how I'm going to plug those into behavior models that then generate device-specific design principles for AR, VR, XR, or gaming or mobile devices or what have you. So this is a very important class for students going through this program. And probably the final class is building the metaverse. The purpose of this course is to have students rapidly build virtual and augmented sensed world experiences using existing tool sets and SDKs. And the experiences to be built will be rapid prototypes of interactive experiences that either focus on R&D with respect to computational human perception, interactive experiences, or potential commercial products in or related to that domain. And key to this course will be the utilization and deployment of behavior models for human and AI characters, as well as bounded sense world architectures. So this course looks like the following. We've got some rapid prototyping of the experiences in AR, VR, XR. We use existing tool sets and SDKs. And behavioral model deployment, there's one for the sensed world, which is what is the overall ambient world that we are in. And we have human models, and we have AI character models. And they all get into the interactive experiences in computational human perception, where we generate interactive experiences or potential commercial products or R&D projects that help us understand humans and their interaction with humans and AI characters. And then the last course, Advanced Experience Projects, is a 2-semester-long course that focuses on team-based interactive experience development, utilizing interpreted biosignals, behavior models that utilize those biosignals for human and AI characters, as well as bounded sense world architectures. And projects proposed for this 2-semester course are approved in the spring semester by a committee of faculty, designers, and venture advisors. And this course looks like this, which is, we approve in this previous spring semester designs, pick a team, and then the interactive experience development goes on with behavioral model deployment for sense world architectures, human models, AI character models. And again, we're building in the computational human perception domain. It's not just a game, it could be anything, any application, and they could be R&D projects, they could be interactive experiences, they could be potential commercial projects. So this is kind of based on some of the ideas that are right out of the USC Games Advanced Game Projects class that I created in 2005. So it's sort of like, now that we've done games this way, how about we build sensor-based sensed worlds that can give us a more interesting experience. So in conclusion, this talk I've outlined, in the most appropriate sense of the meaning of outline, a potential research agenda on computational human perception and its potential at being core for the creation of a human intelligent metaverse. This is not the same. It's not at all the same as the Game-Mod Metaverse currently being flogged to the venture capital community. The creation of a human intelligent metaverse is a sensed world that reaches out from the computational infrastructure and interacts with our physical, emotional, and mental states is a big future for humanity. And part of this proposal is not far away and can be prototyped now. And much of it is farther away than that, but absolutely worth reaching out for if we wish to obtain a world where machines understand and interact with us more deeply than now. Here are some references of papers that you could go after, and I'll leave this up for a second or two and then move on. I've got some acknowledgments. Dennis McBride, a former DARPA program manager of mine and colleague for several decades, wrote back and said, "A program after my own heart, computational perception is the bomb," which to me, I greatly received that. That was nice, because Dennis was always on the cusp at DARPA of figuring out what the future was. Rudy Darkin, a colleague of mine at the Naval Postgraduate School and former director of the Moose Institute, gave me a detailed read and commentary on how to improve what I propose. I integrate all his suggestions, and Rudy wished me well on finding a home for this proposed research and educational program. And Kaiser Kaderi, MD at Stanford University, started talking with me about creating such a program beginning in 2005 when he first arrived at USC, and I wrote the initial draft for the degree program as a distinguished collaborator to Stanford's laboratory. But the plan for the degree has not gone anywhere, but maybe it will someday. Maybe someone will watch this video or read the paper in IEEE Computer and get excited and send us a box of money and a place to build this. This is my contact information, Zyda at MikeZyda.com. My website has all of the IEEE Computer papers there. And you guys all have a nice day. And I will stop sharing here and say thank you for your attention on this talk and presentation, and have a great evening. I'm Mike Zyda.